So when we get a question like this, we can see there's two objects. Because there's two objects, we have to treat them as two free body diagrams. So let's start with this 2 kilogram hanging mass. We know we're going to have a force gravity. Now this force gravity here in this case is going to be mass times acceleration. Now if it's 2 kilograms and it's 9.8, we know it's going to be 19.6 newtons down. I want to leave this 2 kilogram mass for a second. I want to talk about the 5 kilogram mass. We know we're going to have a force gravity. We're going to have a force normal. We will have a force applied, and we'll have a force friction. So the question is, first of all, what is the force applied on this block? Well, why is this block moving? It's moving because of the 2 kilogram mass that's hanging. So in this particular case, this value is going to be the same. It's going to be 19.6 newtons down. We've got the force friction. We know the force friction is going to be equal to mu force normal. My free body diagram is going to get really messy, so I want to take a minute and start trying out the information right here. So force applied, which is 19.6 newtons down. And we've got a force normal, which is going to be force friction, which is mu force normal. We don't know force normal, so we're going to have to hold off and now go here to force gravity. Now we're looking at this 5 kilogram block. So let's just write this as for the 5 kilogram block here. And we can see in this case, again, it's mass times acceleration. So ma. Our mass on here is 5 kilograms and it's 9.8. So it's 49 newtons down. Remember, there's only ever one answer for force normal, and that is question mark. So we work out our net force, which is force gravity and force normal. And it's 49 plus force normal. So we know our force normal is going to be equal to 49. So now when we go to force friction, our mu is 0.25 and our force normal is 49. So when we plug this into our calculator, we end up 12.25. Now this is going to be newtons to the left. That was supposed to be to the right. It's just an ugly R. Now we have to have things going in the same direction. So we're going to make this negative 12.25 newtons to the right. Our net force is equal to force applied plus our force friction. So 19.6 minus 12.25. And when we put that into our calculator, we get a value of 7.35 newtons to the right. So we've solved for our first 3 steps. We drew our free body diagram, we drew our t-chart, and we figured out our net force. Last thing we need to figure out is we need to figure out our acceleration. So we know our net force is equal to mass times acceleration. Our net force is 7.35 newtons to the right. What mass do we use? Well, since the 5 and 2 are both connected, the answer has to be both. So it's 7 kilograms. So our acceleration is unknown. So 7.35 is equal to 7a. And when we put that into our calculators, we end up with a final answer of 1.05 meters per second squared to the right.